Dear students, the question number 36 says that for a metallic conductor, the variation of current through the conductor with potential difference applied across the conductor is shown in the given graph. If the temperature of the conductor is increased, then slope tan theta, the options are decreases, option 2 remains same, option 3 increases, or option 4 which says both 2 and 3, that is both it remains same and increases. Now dear students, we know according to Ohm's law that V is equal to IR. This can be further written as I is equal to 1 by R multiplied by V. Therefore, the slope of current voltage graph would be equal to 1 by R. Now dear students, we know that resistance is related to temperature by a relation that R is equal to R naught 1 plus alpha delta T, where delta T is the change in temperature, alpha is the thermal coefficient of resistance, and R naught is the initial resistance. In other words, as the temperature increases, R increases as well. And when R increases, the value of 1 by R would decrease. Now dear students, in the question it is given that the temperature of the conductor is increased, which means that 1 by R would decrease. And since 1 by R is equal to tan theta, we can also write that tan theta would also decrease. Therefore, the slope of this particular graph will decrease, and hence the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question, which is question number 37. Dear students, question number 37 says that consider a potentiometer circuit diagram as shown in the figure. If the potentiometer wire BD has a net resistance of 15 ohms, then choose the correct statement. For the null point of galvanometer, Bx is equal to 0.5 meters. For null point of galvanometer, Bx is equal to 0.80 meters. For null point of galvanometer, Bx is equal to 0.1 meter. Or option number 4, no null point will be obtained for the shown circuit. So dear students, the question 37 is based on the principle of potentiometer. As per the question, the resistance of the potentiometer wire has been given to be equal to 15 ohms. Therefore, the current that flows through the wire would be EMF of the battery, that is 2, divided by the net resistance of the potentiometer circuit, that is this 5 ohm resistance in series with the 15 ohm resistance, which means 5 plus 15, that will be equal to 0.1 amperes. So now dear students, a current of 0.1 ampere flows through the wire BD. Now let us try to find out the potential gradient. And indicate the potential gradient by a variable K. The potential gradient will be equal to the total potential drop across the wire, that will be 0.1 multiplied by the resistance of the wire 15 divided by total length of the wire. The total length of the wire has been given to be equal to 1 meter as per the figure. So divided by 1. Therefore, the potential gradient is 1.5 volts per meter. Now dear students, for the null point of galvanometer to be attained, the EMF of the battery that is being connected to the potentiometer through the galvanometer must match with the potential drop that is attained in the length Bx. So the potential gradient that is attained in the length Bx can be written as potential across Bx will be equal to the potential gradient, that is 1.5 multiplied by the length of the wire Bx. This should be equal to 1.2. So the length Bx can be calculated to be equal to 1.2 divided by 1.5, which can also be written as 4 by 5, which can also be further written as 0.8 meters. So dear students, the correct answer for this particular question should be option number 2. Now dear students, let us proceed to the next question, which is question number 38. Dear students, the question number 38 says that a positive charge small q of mass small m is projected from a very large distance towards a fixed non-conducting sphere having charge capital Q, charge uniformly distributed inside it, as shown in the figure. The charge small q just grazes the sphere, then the speed of projection u is. Now dear students, in the question it is given that the charge q just grazes the charged sphere. So the trajectory of charge q would be somewhat like this. Let us assume that the velocity of charge q at the time of grazing the sphere is equal to v. Now, in this particular case, the angular momentum of charge small q would be conserved about the center of the sphere because the electrostatic force is a central force which is directed towards the center of the sphere. Therefore, the torque of this central force would be 0 and hence the angular momentum would be conserved. Therefore, the initial angular momentum, which can be written as m into u into d, which is the perpendicular distance, would be equal to final angular momentum, that is m into v into r, because finally at the time of grazing the perpendicular distance becomes r. Herein u can be written as v into r divided by d, or v can be written as u into d divided by r. Now dear students, using the principle of conservation of energy, we can write that initial kinetic and potential energy should be equal to final kinetic and potential energy. Now, since the charge is being projected from a very large distance, we can assume that the initial potential energy is equal to 0. The initial kinetic energy can be written as half m u square, whereas the final kinetic energy can be written as half m v square, and the final potential energy can be written as k capital Q by r into small q, where k is the Coulombic constant. Now dear students, we have to find the value of small u. Substituting the value of v from this equation into this equation, we can write that half m u square is equal to half m ud by r square plus k capital Q small q by r. Now dear students, solving this equation, we can find out the value of u, which comes out to be equal to under root of 2k capital Q small q into r divided by small m multiplied by r square minus d square. So dear students, the correct answer for this particular question should be option number 1. Now let us proceed to the next question, which is question number 39. Dear students, question number 39 says that a potential difference capital V applied across a conductor at 0 degrees Celsius leads to a certain current in the conductor. If the temperature of the conductor is raised by 400 degrees Celsius, a potential difference 2 volt is required to keep the current same as before. The temperature coefficient of resistance of the conductor is. Dear students, we know that in a conductor V is equal to IR according to Ohm's law. Now since the current is a constant value, therefore dear students, we can easily write that voltage must be proportional to the resistance. Now since in the second case twice of the initial voltage is required to keep the current constant, the final resistance should be 2 times the initial resistance. Therefore we can write that the final resistance is equal to initial resistance multiplied by 2. Dear students, since we also know that resistance at any temperature varies according to this law, wherein R is the resistance at temperature T, R0 is the resistance at temperature 0, alpha is the thermal coefficient of resistance, and T is the temperature. Therefore, we can write that 2 times R naught is equal to R naught 1 plus alpha into 400. We are substituting 400 because in the question it is given that the final temperature is 400 degrees Celsius because the initial temperature is 0 degrees Celsius. Dear students, we can cancel R naught and we get 1 is equal to alpha into 400, or alpha is equal to 1 by 400. Solving this equation, we can easily get that alpha is equal to 2.5 multiplied by 10 raised to power minus 3, and the units of alpha is Kelvin inverse. So the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question, which is question number 40. So dear students, in the question it is given that there are 3 identical conductors of identical dimensions. So there are 3 conductors which are connected in series. Let these 3 be the 3 conductors. Now dear students, we know that in the case of series connection of conductors, the net resistance can be written as R1 plus R2 plus R3. Let the length of each conductor be L and the area of cross section be A. We can write R1 to be equal to rho 1 L by A, R2 be equal to rho 2 L by A, and R3 to be equal to rho 3 L by A. Now dear students, if the effective resistivity of the combination is rho, we can write the net resistance as rho multiplied by net length divided by net area. So the net length of the conductor system is 3L and the area of cross section is A. Now dear students, solving this equation and cancelling the common terms, we can get that rho is equal to rho 1 plus rho 2 plus rho 3 divided by 3. So dear students, the correct answer for this particular question should be option number 4. Now let us proceed to the next question, which is question number 41.